Hello, what's up everybody? I'm Keshav and I have created something that I want to show you, and that's a chain reaction kind of game. Chain reaction game on Play Store has got 10 million views, and this game is quite frankly really inspired by that game. So basically this has the game instances set to null, the number of players set to 2, and the player name and basically some variables. These are some random default clear colors, and it initializes the DOM references, and then it updates the player fields based upon the data that is provided by the divs, and it then appends it to the player row, and then we collect this player data, and then we start the game by looping over the number of players and getting their value and putting it in a uh, the player number and player names and choosing color, and then we will set up the container, and we will change the game container style to block, and we will load the game. Now if the game instance is set to true, then we will destroy the previous game and set it to null. Then we have a timeout so that everything can be done without using guessing, right? And then the event listener is set when the DOM gets loaded, and then the number player inputs is so that when a change happens, then it updates the player fields, and it starts the game button, and now it uses the event listener click so that if anybody clicks, then it starts the button, it starts the game, I mean, and then it updates the player fields. Now this is the main phasor game code, and yes, there is index.html and main.css as well. But as you can see, the it just loads phasor.js and some basic div, and the CSS is also for eye candy. So now this is the main stuff, the phasor game code. So it has 8 rows and 6 columns, and if I can show this to you, then yes, it has 8 rows and 6 columns, and now each cell has a size of 60, and the game width and game height are decided using the cell size. And we use -1 as an empty cell in this case, right? Like this might be -1, right? And now the game scene which phasor requires, it extends that, and it creates this. This is just basically phasor stuff, and it has some variables that unnecessary for the game to actually work, like board state, player colors, player active, stored player names, initial player count, current players index, game over, and it's set to false by default because the game is not over, right? We have just started it, and is processing. I'll turns taken this round since the game has just started, then it's 0, and then we convert these from the hex into something that phasor can actually understand, and now we initialize the board state. So it's basically just two for loops to create each cell, and now in when initially all the players are active. This is very important, uh, given that this given that the conditions for winning and losing the game are the same, right? Like in the when you lose the game, you have no orbs, but when you start the game, you also have no orbs. So you need a way to kind of figure out that yes, this is the starting of the game and not the end of the game. So yes, and it was actually a really troublesome way to get that. And now we remove the visuals from previous game instances, and we remove all game objects from previous scene, basically to make it easier, right? Like if any other game was running and now we run another, so it has to balance that out, and this is basically doing that. Then we add the graphics and we draw a grid, and a draw grid is basically a function to draw as many grid columns and horizontal and vertical lines, right? And then we update the status text, and we check if the current player index is a valid winner index, and if they are the winner, then we actually say that the player wins and click to restart. As for, I think I may have shown it to you, but still I want to show it again. So basically, if I can do it, uh, and yeah, player 2 wins, click to restart, and this is basically talking about this, right? And if the player has not won, then we will actually use this to get to the waiting and invalid, and if some else stuff is not working, then we will actually give error. Otherwise, we will just start the game. For example, if I start the game again, so it's player one's turn. It's basically talking about this, right? And we actually get the cell capacity, and we do some logic to figure out that, yeah, the corner, what are the corners and what are not, and to actually set this as 2 for the chain reaction and this as 3, and so on, and 4 for anything else, right? And we then update the cell visual. This is a function for like rows and the column for like and it just has the cell center x and orb radius, and it's basically for the visual stuff that orb actually exists. And then later on we will actually have the text visual like this 1 and 2 2 that occurs, yeah. And this is a text visual, and this adds this text and hides it if it's empty, right? We don't want one to show in an empty cell. So then we handle the player turn over a pointer, and if the game's over, then it just console logs the game over, and game over. Yeah. And then it has this processing, which is a really unique thing that I want to tell more about. And so it basically then floats it depending upon the pointer size, like this and this. So it detects even minute changes, because I haven't added undo button, so I wanted better safety, right? So if rows are less than, so it's basically if it's outside or something like that, then it ignores it, and the cell board state is set. And if the cell owner is empty or the cell owner is current player index, then it actually locks the processing and increases it. And const after, or because you cannot increase anybody else's, right? Though I would love to see that as well. I might create that. In fact, that's a crazy idea. It can have some lot of cooperation and trust. Maybe a multiplayer game if this video gets nice views, maybe. So this dot add soap, and if everything else, then it ignores it. And it also has an arrow, and the cell board state, it counts, it increases the count, and if the count increases the cell capacity, it starts the exclusion chain, and it has some timeout to prevent the async. Now this is the most important function. The start explosion chain has this explosion queue and the processed in this chain set, and then it processes the queue step. It actually has a queue of its own, and it shifts the it actually gets the RNC from its shape, and if we request, if R is less than 0 and this condition is matched, it actually does request animation frame of the process queue step. Now this is one of the most important steps, because this is the main chain reaction stuff. And then it gets the current cell board state, and it changes the owner, and uh, yeah, I get, yeah, this is what I was looking for. This actually looks for the neighbors and of the cell, and it then tries to check if the neighbor itself will do a chain reaction or not. And that is how we get a chain reaction, because it's kind of a loop, but we actually prevent a loop using this function, using this and the previous function, because it actually counts, right? Like we have done this reaction and we don't have to do it again. So it's actually pretty interesting, because I had gone into some loops, and yeah, uh, now once the neighbor cells count, and it actually pushes that again as well, and we request the animation frame, and we check for animation every turn, and if it's game over, then we say that the game is over. Then this increments the game count, and it increments the player count as well every turn. And player with orbs, it starts, mm, and this is basically an array to represent that uh, uh, you know whatever the board position is right now. And yeah, active player is set to 0, and if no player is left, then it will actually go to the game over condition, and it would show that yeah, it has won. And this is basically it. Then some configuration of phasor is required, like the game container from the index.html, and like what game scene that we are, right, like the it was the game scene class, right? And we are using anti-alias because it has smoother graphics, and the width and height are taken from the game height and game width variables. And it will choose WebGL or otherwise Canvas. In my case, it was using WebGL, uh, right? And oh no, I think it was using Canvas because I'm a variable. And yeah, this is it, and you can play the game right now. Thanks.